Welcome students to another video lecture with Mr. Kinnett here. We're building on our previous lesson about how to determine if something is proportional versus non-proportional. And this lesson is going to help us start learning how to graph proportional relationships on the coordinate plane. Go ahead and pause right now and copy down what you see. Awesome. Welcome back, students. So again, we're learning to graph our proportional relationships on a coordinate plane. And our essential question is, how do we represent a proportional relationship on a graph? So just a quick reminder here, we have some facts about proportional relationships. Proportional relationships have to have a constant ratio. Remember, that's really just the unit rate is the same for every ordered pair. And we're going to call this constant ratio, it's going to have a name. We're going to call it the constant of proportionality. And really soon, we actually represent that with the letter K in our equation. And in one of our future lessons here, we're going to start to learn that this constant of proportionality is really called the slope of the line. So constant of proportionality is actually just slope. And we'll learn that in our future lessons here. For something to also be proportional, it has to go through the origin. And if all those things are true, we can write the equation y equals kx. Now, I like to show students how we could get k by itself and start to show you that k is always represented by the dependent variable on the top divided by the independent variable on the bottom. And remember, y is dependent and x is independent. So we draw a vertical line here. And to get the x off of our k, we have to divide by x, the inverse of multiplication. We have to be fair, so we're going to do that to the other side. So it turns out that k always equals y divided by x. So that's why we're placing the dependent variable on the top and the independent variable on the bottom. And this is also true for when we start to find our slope in the future. So k is always represented by y over x. And we can write this equation, y equals kx. So moving on now, we're going to ask you to pause one more time and copy what you see. And you may want to actually have a coordinate plane drawn as well. You can see I only have drawn the first quadrant of my coordinate plane because all this information we have on our table only exists in the first quadrant. So we don't have to draw all four quadrants. Okay, so pause right here and go ahead and copy what you see. Okay, welcome back, students. So in this problem, we're determining whether the cost is proportional to the number of items in each relationship by graphing them on the coordinate plane. And in our example here, we're buying hot dogs and we're trying to figure out how much our cost will be. So start to think this through. Which one of these variables, the number of hot dogs or the cost, is independent of the other? And another way of saying that is which one of these variables is dependent on the independent? So think, if you were going after the cash register, what's going to decide the number of dollars you have to spend on the items? Yeah, it's that number of hot dogs you're actually buying. So it turns out in this problem, the number of hot dogs is the independent variable. And the cost of the dollars is the dependent variable. And that really matters because when we graph on a coordinate plane, you place the dependent variable on the y-axis, and you're going to always place the independent variable on the x-axis. Okay, so we need to start drawing our numbers onto our coordinate plane here in order to start to plot our ordered pairs. So again, this is going to be our x-axis, which in this problem is number of hot dogs, and it's really important that we label our axes with what the information stands for. And our y-axis is going to represent the cost. And it does matter, the cost is going to be in dollars. Okay, so we know which axis is which now. We have the independent on the x-axis and the dependent on the y-axis. Now we have to think about the interval. And what an interval is the number we should count by on each axis. When I look in the number of hot dogs column, I notice that each of these numbers counts by 2. So it may not be a bad idea for me to count by 2 on my x-axis as well. I'm going to actually double that. We're going to go 2, 1, 2, 4, 1, 2, 6, 1, 2, 8. Okay. And notice I'm drawing these lines on the coordinate planes, or it's on these blue lines. I had to actually move my 8 to get that to work. Because it's important to realize that when we plot ordered pairs, we want to use the lines of the graph paper. We're not trying to place ordered pairs in the center square at all. The best place to have them is on those lines because it'll help us in our future. And on my y-axis, we're counting by 6, 12, 8, and 14. I could count by 6s on that axis. That may not actually be a bad idea. So let's see if I can fit this in there. We're going to go with 6, 12, 18. Oh, I'm going to have to go a little higher. 24, but that's okay. I can extend my y-axis up a little higher. There we go. Do you see how I just extended it? Okay, so now step 1 of these directions is we have to plot the ordered pairs onto the graph if it's not done so already. The second part, analyze, means if they already are on the coordinate plane, we would just try to figure out if it's proportional based on step 2. But we actually have to plot our ordered pairs because they're not on the axes yet. And remember, an ordered pair is always going to be x, comma, y. And it gets its order from the alphabet. If you ever forget, the last 3 letters of our alphabet are x, y, z. Okay, so our first ordered pair is this 2, comma, 6. So we're putting those on our graph. We need to plot at 2 on the x-axis up to 6, and that's our first ordered pair placement. The next one is 4, comma, 12. And then the next one is 6, comma, 18. And the last one is 8, comma, 24. Okay, so we have our 4 ordered pairs on there. Well, what does the next direction say? If the ordered pairs are in a straight line and the line goes through the order, well, if it's a straight line, they look like they're in a straight line, but we actually have to connect the dots. And sometimes my horrible joke would be to connect the dots. Connect, right? No. Okay. So we're coming all the way down. Oh, now that we drew that line, it does actually seem like our relationship is going to be proportional because it goes inside or it touches the origin here at 0, comma, 0. So remember, origin stands for the ordered pair 0, comma, 0. Okay, so let's find out if this does work. We did end up in a straight line, which does mean that our relationship here has the same unit rate or constant ratio or constant of proportionality. And then secondly, we have to make sure, does the line go through the origin? Yep, it touches the origin right here. So we do know that this relationship is proportional. Okay, so what we've just discovered is this is proportional. And that's because it's a straight line, meaning it has a constant ratio or a constant of proportionality. And it goes through the origin. So we visually know this is a proportional relationship. Now, the other cool thing about if it is proportional is it turns out if it is proportional, there's an ordered pair that will give us the constant of proportionality, that k value we're learning about. And that ordered pair that gives us that constant of proportionality is at 1, comma, r. And even though that one hot dog purchase was not inside of our table here, our graph has shown it to us. It's been discovered. Right here is 1, comma, r. And that's kind of why I counted the way I was counting to make this easy to read. So this ordered pair is the ordered pair 1, comma, and I counted by 3's on my line. So that's 1, comma, 3. So it turns out that the ratio or the k value for this problem is $3 per hot dog. So we've discovered our constant of proportionality by graphing this time rather than our previous lesson where we learned how to do it through unit rates. So we got to answer our question finally here. It did ask if it was proportional based on the graph, and I like to teach you to write your answers out. So the relationship of hot dogs purchased to cost is proportional. And I spelled proportional wrong. Someone will pick on me for that. Okay. And then we also have discovered, since it is proportional, we can check the ordered pair 1 comma r, which in this problem is 1 comma 3. So the constant of proportionality is $3 per hot dog. Well, that's it, students. We're learning how to graph our proportional relationships. We're learning how to connect our ordered pairs to just see if it goes through the origin location. And if it does have all that true, there's an ordered pair on our graph that tells us exactly what the constant of proportionality is. So this is a different way than doing the unit rate for each ordered pair. Just so you do see, if we did 6/2 hot dogs, I'm going to use a HD, and we did reduce those by the 2/2, it would equal $3 per hot dog. And it does turn out that is the constant of proportionality. So remember, if you have any questions, write them in the columns here, in that question column. You can ask me when I get back, but don't be afraid to ask the substitute. Thank you, students, so much for this lesson. I'll see you again.